Okay, so step 4. Step 4 is the electron transport chain. Now I'm going to keep it simple, so I'm not going to go over all these steps. But let's rewind. So we have step 1, glycolysis. What is the end result? You have 2 ATPs and you have 2 NADHs. Then you have step 2, which is Pyruvate dehydrogenase. What's the end result? You have a formation of 2 NADH pluses. And then step 3, you have the Krebs cycle. So what's the end result? You have 6 NADHs, you have 2 FADH2s, and we have 2 ATPs. Now, one thing to keep in mind, that the NADH and the FADH2s, they're very important because why? Because they're the input into the electron transport chain. And they're oxidized. Okay, so the electron transport chain, it's still in the inner mitochondrial matrix. Again, it's a series of steps, but I'm just going to keep this very, very simple because I'm focusing more on what is the net result. So the end game with the electron transport chain is you're taking the NADH pluses and the FADH2s, and the end result is for every one NADH, you're going to produce 3 ATPs, and for every one FADH2s, you're going to create 2 ATPs. So how many is that? So you have 10 ADHs and you have 2 FADH2s. Times 3 is going to bring it to have 30 ATPs. The FADH2s times 2, you're going to have a net of 4 HTPs. Add those up, you're going to create 34 ATPs. However, remember, in glycolysis, you're still going to add up those 4 ATPs to have the to have the last final product of 38 HTPs from the electron transport chain. So I hope you enjoyed the video. I hope this helps. See you next time. Thank you.